Hello, I am a Christmas pudding this evening. I'm feeling very festive this evening, so I'm got my Christmas jumper on, and it's a bit cold in the workshop this evening, so I've got Christmas hat on. Because it's Streammas. It's Streammas. I'm streaming every single day in December. Yes. How's it going, guys? Good evening. Good evening to you. This evening we're going to be looking at a few smaller amplifiers, stuff that maybe you might be able to get your hands on and pick out and buy for cheap if you're looking at getting started in amplifier repair. So this might be a cool one if you think about taking this up, giving it a go. Got a couple of small Class D amplifiers, monos, and then a Class AB4 channel. So we're going to see what kind of issues come across on these. To be fair, it's the same kind of stuff as the bigger amps, but it's just easier to have a look at it in a smaller form factor and relate to it a little bit better. How's it going, Daniel? Nice, awesome stuff. That sounds like, oh yeah, wait, it's Friday today. Holy crap, that's crazy. This week has gone mad fast. So that's pretty cool. No, L3NOX, whatever your name is. This is not a Premiere. I just nicked the Premiere intro for YouTube because I didn't have time to write an intro for myself. Maybe I'll do a Streammas intro. So anyway, what do we have on the bench this evening there? We have a Pioneer GMD 9601. This is a very, very popular amplifier for budget basing. This makes about 1,350 watts RMS into 1 ohms, and it's actually a pretty well built little amplifier. The circuit in this is pretty nice. We have, from factory, we have 3205 MOSFETs as standard across the board, and the outputs we have 6 IRFB 4227s, which are pretty beefy MOSFETs for the output section. Driving the output section, we have an IRS 2092S, which is a pretty decent drive circuit, and these chips are the protection on these chips is a bit better than most, and also the drive circuit is buffered. So the drive IC is here, and then we have a bunch of buffer transistors over here for the output section. So overall, not only that, nice big beefy transformer for the power handling of this amplifier, only being 1300 watts. Nice big transformer. We also have power line filtering. This little inductor here is sitting on the 12 volt power line, and it filters between the it basically filters any noise coming back down into the 12 volts of the car from the transformer ringing, which is also nice. On the output section, we have this very well seated down inductor here, and then we have a couple of really big beefy film capacitors for additional filtering, and a final second stage filter inductor. Basically all types of filtering possible on this output section. You got this inductor, film capacitors, secondary inductor, and a bipolar aluminium capacitor here as well. Yeah, basically filtering out all of that nasty spikes and stuff that Class D output sections generally tend to make and send to your subs. So yes, cool. How is it going, guys? All the capacitors, yes, all the capacitors. All of the capacitors. How many capacitors does it have? All of them. Yeah. So they decided on the rail capacitors. They decided to go with multiple smaller capacitors. This is a really freaking nice amplifier, to be honest. Like this thing's a little beast, man. It's so cool. A little Pioneer GMD 9601. The 9701 is the same, just looks a little different visually. But obviously this one has failed. So as good as it might be, and as much as we can big it up, this one has failed. So let's see exactly why it's failed. Visual inspection shows us that we have some problems here going on with the power supply MOSFETs. Now I've lowered the frame rate on this camera, which obviously isn't nice, but it gives you a better picture at this higher resolution. Just have to cut the frame rate in half a little bit. So as you can see over here, if I take this MOSFET clamp off, the clamp is actually stuck to the FET. That's how much heat there was. And we're going to focus. Yep. So we can see here, if we get it out of the shadow, this MOSFET looks like it bit the dust. Yep, that's burned up like a crisp. So power supply section needs rebuilding. Let's get rid of that one. Let's see if we have any more burned ones underneath this. Oh yes, we do. So all the power supply FETs have burned pretty much. Even the ones that look okay are probably shorted internally. So power supply rebuild on this one. In terms of the drive circuit for the power supply though, Now, I was saying last night in my stream that when you're talking about the power supply drive circuit, whether it has survived or not, you can get a relatively okay-ish idea as to the condition of the power supply drive circuit by looking at the condition of the gate resistors. So the reason that the drive circuit fails in the power supply section is because 12 volts gets sent down from the MOSFET down the gate, and it gets sent to the drive circuit over here in this amplifier, the little power supply drive circuit over here, and what it does is it sends the 12 volts to the drive circuit, which the PNP drive transistor, which is connected to ground, it grounds the 12 volt coming from the FET, and so that all burns up. But while doing so, usually it will also burn the gate resistor, because the gate resistor is in series with that PNP transistor that's going to be grounding all the 12 volts and causing all of the burning sensations. But over here it looks like the gate resistors aren't in too bad a shape. Often when all the gate resistors look perfectly clean, the drive circuit has normally survived. So I think the first thing that we should do on this one, before we even look at the output section, just let's just cut all of the, get all of these power supply FETs out of the way, and just check the drive circuit condition, because I reckon it might be okay, you know. Might not have to do the drive circuit. So yeah, if you're not sure where the drive circuit is in an amplifier, all you have to do is take your multimeter and trace back from through the gate. Ooh, this I hate it when all of my leads and everything get covered in thermal paste, because then it gets on all my clothes. And as you can see, I'm wearing my best jumper this evening. I don't want to get thermal paste on my Christmas pudding. I don't recommend putting thermal paste on your Christmas pudding. It doesn't go so great. Brandy, yes. Actually, I freaking hate Christmas. Oh, Christmas pudding is disgusting. Who here likes Christmas pudding? I'm not a fan of a fruitcake. Like in my childhood, I had the misfortune of mistaking fruitcake for chocolate cake, and so I rolled up to this cake table and I was like, "Damn, son, there's a big ass chocolate cake. I'm gonna take myself a slice." So I grabbed a slicer, pulled off a massive chunk, like, you know, decent enough size for a kid, and started munching my way. Took my first bite. I was like, "Bleh, bleh. What is this? Dead flies, raisins, cherries, all kinds of janky moldy fruit. Disgusting. I could not eat that. And since then I have not liked fruitcake or Christmas pudding or any of that nonsense. Give me a chocolate cake any day and I'm happy. But yeah, all you have to do is you just have to trace with your multimeter from the gate of the MOSFET that you want to know where the drive circuit is for. So in this case, we're looking at this MOSFET here. And then you just want to kind of look back through the gate resistor, which in this case is a 47 ohms. Yep, that's reading within tolerance still. And then you just want to kind of go back and look over, usually near where the TL494 circuit is. So over here we have a TL494, that's been identified here. And around here somewhere, there'll be a group of transistors, maybe, and it'll be an even number of transistors, like 2, 4, 6, 8, etc. And they will have continuity to the gate resistor that you just measured. So in this case, it's these four here, these four little transistors. So if we check continuity, see here, beep, we have continuity to these two here. So these two, NPN and PNP, are driving this bank of power supply MOSFETs. Pretty easy way to see where your drivers are in the board. What's everyone think about Christmas pudding, hey? Try not to chew FETs tonight. Oh no, I swear, I still had that in my throat. Like, you know when you you take a pill or some medication or something, and you feel like it's stuck in your throat, and not actually going down. You're like, come on, get down there, glugging juice and eating snacks, trying to get it to go down. I felt like, that's what I felt like for the whole of last night. I felt like it was still in my throat. Do you like eggnog? Oh, what the hell is eggnog? I'm not even sure. Eggnog's an American thing. Is there a... What's the British word for eggnog? What the hell is eggnog? Has it got anything to do with eggs? Because, like, obviously the name suggests it does, but these things can be deceiving. I was tempted to potentially do a top board repair, but I don't know. I'm not sure actually. With the power supply FETs burned like that, there could be traces on the underside of the board that are actually fused traces. So it's very tempting to do a top board repair all the time. But when you got a power supply that's burned up, yeah, you might as well just take them all out. Also, there's another funny thing in this amplifier. Check this out. These guys. Look over here. Here we have the RCA inputs. And you can see here that some guy has just like obviously snapped off the original RCA tips. Top and bottom actually, both of these. And then rather than trying to get them out, has just gone, let's just send it, and thrown in, like literally jammed in another RCA cable and just pushed the pin through. And to be fair, it probably worked because it was still making a connection on that pin there. So just gonna kind of try and get that back in there. There we go. We've got the bottom one as well. Alright, let's see what are people saying about Christmas pudding. I'm really intrigued. Sick bag cake. I agree, Rob. I absolutely agree. Ham. Do you like eggnog? I make my own fruitcake with rum. I'm still not sure about like spirits in cake. I don't like it. Kind of leaves. It's kind of alcoholic tasting cakes. Nah, not so keen on that. Crumpets, not fruitcake. Crumpets is where it's at. Tell you that. What is Christmas pudding? My man hasn't even had the nightmare, hasn't even had the trauma of Christmas pudding. Man, stay that way. Don't even go looking for it. It's not great. You don't know eggnog? Nah, man. Maybe do we not get that in the UK? I don't know. I've never come across eggnog before. Trent B, what are you looking for, my man? FETs exploding? Do you want some FETs blowing up? I mean, I could maybe take an old FET and just blow it up on the bench for you, like somehow maybe. I'll tell you what I could do. I could get a FET, put 16 volts across drain and source with 20 amps. I've only got 20 amps available, and then just like turn the gate on. If you want to see a FET blow up, could try and do that. I don't know how well it would blow up only given 20 amps, but we could try. Sup. I throw them Pioneers in the closet for 20 years until someone will fix them. Nah, these ain't too bad. They're usually pretty quick to fix, to be honest. These things, because these Pioneer amplifiers, because the output drive IC is buffered, most of the time it doesn't kill the output driver. Sometimes it does, but most of the time it doesn't. So usually they're a pretty quick repair. So I don't mind doing these little ones. You're helping a guy out as well. You have to remember that, like, guys giving you these smaller amplifiers, especially decent smaller amplifiers. Like, okay, if someone brings me some bullshit bass face or some really crappy like amplifier that's really been poorly designed and that's blown up, so I'll probably say it's not worth repair. But this Pioneer is a really well designed amp, so I wouldn't want it thrown away. It's nice components. It's gonna do someone nice for some bassing, so I don't really want to, you know, let it get thrown away. And usually the guys that are buying these kind of amplifiers are on a budget, you know. So if they've got an amp, it's probably cheaper to get an amp fixed than to buy a new amp. So I'd rather help a brother out and, you know, get it fixed for them. So it might not be too much worth the time, you know. My time might be better spent doing other things, but at the end of the day, I like fixing amps. So if I didn't, I wouldn't be doing it. Okay, is that everything? Is that going to come out now? So these MOSFETs as well, someone asked me not too long ago, they were trying to take an amplifier apart and they said, oh dude, I've unscrewed all the screws everywhere, but there's something still holding the amp down in the case. And yeah, it turns out that a lot of people don't realise that the TO220 package parts along the edge here, they actually stick to the thermal tabs, the thermal strips. Okay, what are we missing? What else are we missing? I missed a screw somewhere? Oh yeah, there's one last screw just by these capacitors, hiding away, tucked in there. Loads of screws. So this amplifier as well, again, very nicely built. It shouldn't suffer from vibration damage either. It's really well put together. I mean, the transformer, I'm not gonna lie, could be a bit better. There are some stray leads here, just kind of floating around. That could be a bit better, but you know, at the end of the day, for a budget amplifier, it's pretty good. So many freaking screws in this thing, jeez. Okay, now we out. Now, oh, one more screw still, bruv. What are you doing? Ah, right. I like full range class D. Okay, cool. Well, there has to be someone, I guess. Okay, let's see. Was it pointless to take apart the whole case? In this one, yes it was. So the only reason I took the amp out of the heatsink in this one, rather than doing a top board repair, was in case there were any blown traces on the bottom of the board for the power supply, which there wasn't. You should check it every time anyway, but it's just annoying. I'm like, could have just repaired it without taking it out of the case and saved myself some time, but that's cool. Okay, let's start off then by removing. Actually, no. Let's power it up straight away then, and let's show you guys whether the drive section survived, whether my predictions are true or false, going by the condition of the gate resistors and also visible condition of the drive transistors. Like, they didn't look so bad, hey. Drive transistors on this one are just over here, and these look pretty good. They're not like, there's no burning, there's no kind of darkened marks on the board from where these are. Like, when these cook up, they get really hot, and they're very small, so they're very easy to tell usually when they're kind of going bad. So I predict that the drive circuit's probably going to be alright on this one. I just want to see if my prediction is true. So let's plug her in and find out. Mike Honda, what's up, bro? How's it going? I'm a Christmas pudding this evening, if you haven't already noticed, and we were discussing whether we like Christmas pudding, and I think the general consensus is that I think most people that commented said they don't like it. There's a couple of people that like it, I think. Sakura says, what do you plan to work on? Wait, when do you plan to work on that power acoustic? Oh, that old school one. We could maybe look at it this evening if there's a calling for it. If people want to see the old school power acoustic work, then I could do it after this one. Michael Davidson, do you like Earthquake D2 old school amps? Wait, there's another comment. It's blown, I'll send it to you if you make a stream about it. It's supposed to make 7,000 watts RMS. Holy crap, really? I don't think I've seen this one. Let me see this. Earthquake D2. Let's check this bad boy out. Earthquake D2. This one? No, this one? 2K at 2 ohms? Earthquake PHD2. This one? Wait, where's the photo that it gave me? I hate this! Literally! Google Photos, there's a photo there, but then when you click on the page, it doesn't actually take you to the freaking photo. That looks like similar to... I recognize this board. I think this might even be full bridge. Yeah, I think this is even full bridge. Well, a really early full bridge. Interesting. I mean, if you're not in the UK, it's going to cost you too much to post it, so I wouldn't worry about that. Maybe you can learn to fix it by watching my videos, or maybe we could fix it together on a Zoom call or something like that. Anyway, let's get back to this. So let's power up and let's see if the drive circuit did survive. My guess is that it probably did in this case. Power supply on, low current, 10 volts, minimum amps. Okay, let's see. Oh, okay, so don't seem to have any power at the moment. Did the fuses blow? Nope. Oh wait, there we go. I was clicking on the wrong foot pedal, that's why. Okay, drive circuit, where you at, boy? God damn it. Okay, cool, so that's one bank of power supply drive. Looks pretty tasty to me. Let's check the other. That looks good. Oh, that one's not so good. Oh no, that was the 12 volt pin. I was probing the wrong one. Yeah, that looks good. That looks good, and that looks good. Okay, cool. Yeah, so power supply drive circuit did a cheeky survive on that one. So I haven't got to replace any of the drive circuit, which is cool. So I can load up a fresh batch of 3205s. Easy. Now let's turn our attention to the output section first before we go loading up any of those. So why did the power supply fail? As I've explained many times, usually the power supply only fails. The only reason the power supply will fail is due to output section failure. It's more rare for the power supply section to just die by itself, unless it's a tower amps, because tower amps have poorly designed power supply sections, which is where that, you know the whole reason about the whole thing about Brazilian amplifiers catching fire mostly stemmed from tower amps, because when power supply sections blow, they generally smoke and fire, whereas output sections don't smoke and fire. So tower amps amplifiers, they have an problem with the design of the power supply section, and it dies all the freaking time. In the old HD line, not so much the newer stuff. Tower amps newer stuff is much better, but the older original HD line and stuff like that, the power supply section was freaking stank, and that's where the whole Brazilian catching fire thing came from. Stetson were also similar, but they also suffered from vibration damage issues, which killed the power supply section, which caused smoke and fire. So that's another reason that Brazilians were seen as catching fire. But to be honest, like all the others, Banter and Sound Digital, and any of the others, can't think of right now, causes. But generally, when the amplifier fails, when the output section dies, because those amplifiers have a built-in health check mode, they won't kill the power supply section when the output section dies generally. So if anything, these new Brazilian amplifiers are going to catch fire less than the old school Korean half bridges, which don't have any protection on power up, and they will smoke the power supply section if there's a dead output FET. Nice one, Strictly Amps. Dude, thanks for the 25. Merry Christmas to you too, buddy. Appreciate that. That's a pretty ball-in donation. Thank you very much. Massively appreciated, dude. 25. Awesome. Thank you so much, buddy. I really appreciate that. That's very kind of you. Let's continue with this this output. Oh, fuck's sake. It's gonna this is just gonna be one of those days, isn't it? I had this yesterday where I say a bunch of stuff like, oh, the power supply section will never die if the output section hasn't failed, blah, 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 blah. And in this case, we don't seem to have any dead output FETs, so that would mean that the power supply has died by itself. I always get interesting ones on the stream, like literally, like when I'm not streaming, I'm just working. Like obviously I haven't done any videos for a while. I've been working all day for like 6 months and repairing amps coming out my ears all day. I would say that probably like 85 to 90% of the amps that come with dead power supplies have dead output sections, so just the ones that I decide to tell you about that then don't. Alright, this one could be nice and easy then. Nice cheap repair for the customer. Literally, the only thing I think that we need to do to repair this amplifier is just fit new power supply FETs. Nice and easy. Okay, yeah, sounds like a bunch of you guys want me to check out the old school power acoustic. So we'll do that next. Beverage, I got the yellow ones ordered, huh? Wait, Dan. Say what? The yellow what? I can't remember. Sorry, I can't remember if that was a conversation we had the other night about something. Got the yellow ones ordered. I mean, yellow's good. Oh, wait. Yellow screwdrivers. Yellow. Ah, yes, yellow screw. Is that what that's about? Yeah, yellow is a great color. Hey. Seeing as my car is bright yellow. Damn, man, these Pioneer boards have some serious thermal mass. Well, it could just be that my soldering iron tip is finally completely dead. You know what? I'm not even sure I can be asked to do this right now, because this soldering iron tip is freaking toast. It's not heating up at all. It's all bent, and the heating element is just not connecting properly. So what I'm gonna do is I'm gonna just temporarily solder a couple of FETs one per bank. Just literally all I need is 2 FETs, because there's only one transformer, so I need 1 FET per low side, 1 FET for the high side. Just to show you that this amplifier probably works, or just to, you know, just to see if this amplifier actually works. I'm not even going to use 3205s, just going to throw in some 65 NF06, which come from bass face amplifiers. There you go, one on this side. And then just need one on this side over here. Because I reckon a lot of you guys want to see the power acoustic, so I want to jump onto that as soon as possible, rather than just fitting power supply FETs, because that's boring. Okay, cool. That's 2 FETs very jankily soldered to the board. So let's just see then the amp come on, and let's just check that the see if there's any underlying reasons that the power supply failed. So I can't really see any reason that the amplifier failed, other than potentially, actually, I think he might have said that he wired it up backwards, which would explain why the power supply failed by itself. That's one of the few reasons that the power supply will fail by itself. See if the amp is hooked up backwards. So let's just take a quick look on the old scope screen here. And get my buttons working. Fucking hell, man. There we go, finally. Okay, power, and we are liftoff. Yep, 0.4 amps, 0.9 amps, because the output section is now kicked in. Jumping around a little bit. There we go. Output section, let's have a look. Yep, we have output switching. Looks good. Yeah, weird. I reckon this might have been hooked up backwards, or just some random occurrence causing the power supply section to die on its own there. Very, very strange. Let's turn the voltage up a little bit. Let's go up to 14 volts. Yeah, still good at 14 volts. Cool. So literally, very, very cheap repair. All it needs is 8 power supply MOSFETs. That's all that one needs. So yeah, that one's boring. Let's put that down to one side, and let's take a look at this old school power acoustic for you then, because that's a bit more interesting. Let's just put the parts for that amplifier in a little bag here before I lose them. There's many screws. Many screws for that one. So, do you want to know something funny? Who remembers the video we did on day number 1 of Streammas, where we repaired the bass face DB 1.3 that was really fucking crazy and it was 4 hours long? Who was there for that? Some funny news about that amplifier. Yeah, this Xmas jumper is sick. I am the Christmas pudding. Which is disgusting, but that's cool. Yeah, here we go. Power acoustic. Okay, let's see what's going on. I think this is probably just going to be another boring repair. I think this is probably just going to be a solder bridge, but at least we could check it out and see what this amplifier is all about, hey? At least we could actually see what this amplifier is all about. It's got some sticky residue on it, which is a shame. Actually, I could probably get that off with some isopropyl. It's got like... what? Who would put this double-sided sticky tape... Oh, wine gums. Wine gums are super tasty. They're delicious. They don't taste like wine. They just taste like good fruit. They're really nice. Really nice. Yeah, the Smart K is definitely one of the best things to ever come out of Brazil. Hands down. The Smart 3 is a beast. It's awesome. Who likes a good VU meter in their amplifier? Good old VU meter. Yeah, so the bass face amplifier from the other night that we spent ages repairing. The customer obviously said that he doesn't want to pay for the repair of that one because so that amplifier, I think the amplifier in used condition is worth about £150, 150, £160. The repair would have cost about £150 to £160 on that one, and you can buy a brand new board, internal PCB, whole PCB for those amplifiers for about £70, half the price of the repair. So naturally, he said he doesn't want to pay for the repair, so that's fine. So I was thinking, okay, I'll just get to keep this blown board as a spare, and it would be nice and handy to have it repaired, obviously. But no, he wants the original board back because he wants to try and repair it himself by watching some YouTube videos. So now, obviously, I repaired it already. So I can't give him back the amplifier repaired because, like, without being paid for the repair, right? I mean, yeah, I already spent the time repairing it, but I'm not just going to give him a free repair because that's not fair on anyone else, and that's not how I run a business. So I had to spend some time yesterday undoing all of the repairs that I did. So I had to take all the new FETs out, and I had to put back in the shorted 5-volt regulator, just because if he wants to try and repair it, he needs to understand how complex that repair was, and if he wants to try and repair that, then that will be a good challenge for him. So rather than just give it back to him repaired and just not get paid for the repair, I'm going to put it back to how it was before and see how he does with it. What's the use of UV or VU meters in the amps except looks? It's literally, yeah, it's just a visual indication of how much, how close to the limit the amplifier is, because at the end of the day, this will be the sine wave amplitude. So you'll be able to see exactly how close to clipping it is by looking at the VU meters. It won't necessarily tell you how much power the amplifier is doing because the load is reactive, the ohm load is reactive, but when this little needle gets up to 0 dBs, that is the clip point, and then anything above that into the red should be, provided the VU meters have been calibrated correctly, should be into clip at that point. Now does this should just slide out, right? But there's something preventing that from sliding. Can't quite see what is preventing that from sliding, but something is preventing that from sliding. Oh, no, just some tape, probably. Okay. Should we do a zoom? Yeah, Chris, yeah, exactly. I'm like 8 hours into that amp and I'm not getting paid for the repair. But fortunately, you guys got to see the video, and obviously I did a live stream with it. So I used it to create some content. So I'll just have to treat it as like that. That's fine. But I'm definitely not, I'm definitely not giving him any free MOSFETs, like, whatever it is. I think there's like 24 3205s in that amplifier, and then like however many, I think it's like 12 640Ns or whatever. I get to keep those, obviously. I'm not giving him any free parts. So apparently, according to the guy who owns this, he says that the amplifier doesn't come on. There's no sound, there's no life, the VU meters don't move. All there is there's a little red LED over here. Now this little red LED is right next to the 494 chip. So I would say that red LED is signifying that there is maybe 12 volts VCC for the chip to use. Now this board is a single-sided PCB, which means that it's good practice to take it out of the board completely and check the back of the PCB, as these often tend to suffer with like cracked solder joints, because obviously being a single-sided PCB, these parts are only held in on the backside rather than being held in top and bottom, which gives them much more sturdy kind of mounting. So any kind of vibration does tend to affect the solder joints on the backs of these. Now these are some really freaking old output transistors. So the TIP 36 and 35C are still used to this day, but these are some really old ones. These are Morocco, and this package style is freaking ancient as well. You don't really see this so much anymore, this package style either. So yeah, I think, is this a little mono? A little mono block? Yeah, this is a little mono block, little class AB mono. Cool. It's got a single, what looks like a 25 amp fuse. So this amp's probably going to be doing no more than about just shy of 300 watts RMS with a little bit of soft clip. Actually, no, class AB, holy crap, it'd be even less. I think this amplifier is probably only going to be putting out about, I don't know, freaking hell, just about 200 watts RMS. So it goes to show you that this amplifier is not really any use to you these days, you know, modern stuff. The size of this amp is probably about, it's getting on for twice the size of a Taramp Smart 3. So a Taramp Smart 3 is capable of like 3,000 watts at 12 volts. So when you're comparing 14 volt ratings, it's more like 4.2k. So the Taramp Smart 3 is like 4.2k, and it's like, you know, just a little over half the size of this amplifier. And this thing's like what, 200 watts? Man, we come a long way. We come a long way. Okay, so these transistors will definitely be stuck to this thermal pad. No doubt about it, because this is so old. It's been clamped on there for years and years. So just pull that away, like so. All these TO220s as well. The power supply MOSFETs this is using is IRF Z44N, which was a fantastic MOSFET actually for its time. Used back in the day, used on these amplifiers. RF Z44N, really nice MOSFET, and it's also not fussy with running in parallel with other 44Zs that are slightly different batches or tolerances. They're a very diverse FET. They don't care too much about what they run in parallel with, provided it's the same model, of course. Okay, so let's have a look on the bottom then. Are there any obvious signs of cracked solder joints or anything like that? With an amp this age, it's worth taking it apart fully and just checking all of the solder joints and looking very carefully, seeing if I can see anything untoward. You know what, it actually looks pretty good down here. It looks like pretty clean, looks like quite new. You can see here where there were areas of the board that have ran hotter than others. So here you've got this kind of yellowing, which is from the solder flux that was on the board, and it's kind of heated over time. And that is, well, what was that? That looks like it's just under, got a couple of pull-down resistors, got the rail capacitors here. I doubt they've got hot, so I'm not sure where that heat's come from. You should probably get some heat over this end. Yeah, a little bit of heat around here where you've got the big current sharing resistors here. Well, this diode over here, this is for reverse polarity protection. You've got an inductor here, which is for that's on the 12 volt power line, which prevents noise from the transformer ringing back through the rest of the system. But apart from that, yeah, it's a really simple board. Like, you know, this isn't anything special. It's an old school amplifier, but honestly, it's very, very basic. It's nothing special at all. You know, it's a cool little thing with the VU meters, but nothing special. So I can't immediately see any obvious issues that would prevent this amplifier from powering up. All the solder looks pretty good, to be honest. Looks pretty good. The rectifiers, they could prevent it from powering up if there was a problem there. With an amp this old, it is actually more likely, like the chances of this happening gets greater the older the amp gets, that the TL494 has just given up. The TL494, you know, is running, creating PWM all day long. The older the amp gets, the higher the chance that just fails before anything else. So let's plug it into some power then, and let's see if we can get to the bottom of what the problem is here. That's one thing that I'm really glad hasn't stuck around. These crappy power terminals with these square washer things. Actually, this isn't even the right size screw. It's just kind of jumping around in there. Yeah, these have either been threaded or they're the wrong size screws. All three of these, actually. Yo, Stormy Young! Stormy Young, thank you very much for the 10, buddy. What's some of the best amps for the money? At the moment, the best amp for the money, hands down anywhere, is the Taramps Smart 3. It is a fantastic amplifier. I can't stress this enough. Go and watch Big D Wiz's YouTube video about it that I did a segment on, and you'll understand a little bit about the Taramps Smart 3 and why it's so good. Why, for the money, like, oh man, in the UK it's like 200 and something pounds. It's like so cheap, and it's like 4.2k at 1 ohm and 2 ohm. It's such a crazy little thing, man. I'm just trying to find some more of these screws that are the right size. I don't know if I'm going to find any. Because these are just falling straight in through the hole. Like, I'll put this in here. I don't think I even have to screw it. I think I'll just push straight down on it and it'll just stay in. Stormy Young, I need something like a 6 or 8k. If you want something with that much power, I would say check out. There's a few options. Depends how much you want to spend. So best value, best amps for the money. Okay. So I can't suggest anything from B2 Audio because they're expensive. So they're very good amplifiers, but they are expensive. I would probably still recommend the Banter Viking 8K. If you get that, it's a 10k amp at 14 volt. If you get that, and if you run it like down at like 6 to 8k, it'll be absolutely fine, and it sounds fantastic as well. They're really well built amplifiers, the Banter Vikings. The problem is some people just don't know how to use them, but they are really good amplifiers. They are built twice as strong as any other Brazilian amplifier in the same class, like in terms of what parts are being used. For example, the Banter 8K uses 8 90N20D output MOSFETs, whereas the Taramps 10K only uses 4 of the same FETs. So you got twice the number of FETs in the Banter to help dissipate power and heat to the heatsink. Yeah, they're just a better amplifier all around. I've been struggling to find a good supplier in the UK for Taramps. Can anyone help, please? The only way that you can get the Taramps in the UK at the moment is to order directly from Brazil through eBay. You go to eBay, type in Taramps Smart 3, you'll see that they are available on eBay. Direct import from Brazil for like £280, which is really cheap. And you are covered then by PayPal and by eBay buyer protection. And I personally know the guy running that eBay store in Brazil, and he's a nice, legit guy. You're going to get your stuff, and it works. It's new stuff, so don't worry about ordering it directly from Brazil from the eBay. The seller is lovely, and you will get your stuff. Alright, let's turn this amplifier on and see where the issue is. The customer on this one said that the amplifier was appeared to be sort of turning on, but there was no life. So you just got this little red LED here, but you got no power in the VU meters, you got no output, no nothing. So yeah, let's just see exactly what happens when we apply the power here. Let's give you the scope screen in the corner so you can see. I'm going to probe the power supply MOSFET. Ah, okay. Yeah, he's right. So, as you can see there, we've got the little red LED come on when I touch the remote. Yep, little red LED comes on. However, if we take a look at... Oh man, this thing, man, why is this not working? I've got a button down the side to switch to my scope view, but it just never works. Scope view, here we go. Yeah, if we take a look at the scope view, so when I hit the remote, you see I just get this little bit of noise here. I don't actually get a square wave. What's on the gate? So why aren't we getting a wave on the power supply FETs here? Let's have a look at what's on the gate. Interesting. We do actually have drive of some sort on the MOSFET gate, but on the MOSFET drain we don't actually have anything. That's why we don't have anything on the MOSFET drain. So the drive is good. Here we go. Here's the drive. MOSFET drive looks good. However, on the drain we don't have anything. But if we probe the third leg, oh, you can't see because it's all covered in crap. Look at this. So leg number 1 is the gate. Leg number 2 is the drain with just 12 volts on it and basically no drive. Leg number 3 is supposed to be ground. So we're supposed to have 0 volts here. But what do we have? We have 5.1 volts. So that, my friends, means that this amplifier is not grounded properly. There's some problem with the ground. So we don't have a decent enough connection from the MOSFETs ground and the amplifier's main ground terminal. So this is going to be a nice easy repair for the customer once again. Let's take a look on the back of the board then, which is probably where that issue will lie. We want to measure resistance between the power supply MOSFET source and ground terminal. And let's have a look on our multimeter. What do we have? We should have a direct connection because that should be grounded. Except we don't. We have what looks like 700, 800 something ohms. Let's go 2K here. Let's have a look. See how many ohms have we got between these two? Damn, it's in the thousands. Damn, it's like really freaking in the thousands. What the hell? Damn, it's just a capacitance. Ha! What the hell? Okay, so we have complete open circuit and there's just a diode reading there or something. Maybe it's finding ground through this this diode here. Yeah, it's probably finding ground, just leaking a tiny bit through this reverse polarity diode. So, okay, the amplifier is not grounded properly. Let's have a look and find out. Oh, I see our problem. Visual inspection didn't work too well because I missed a clear problem. I missed a clear issue here. Oof. This, my friends, is why the amplifier is not working. So this is the ground trace for the power supply MOSFETs. And as you can see, it has blown straight open. Which is curious. I wonder whether we have blown power supply MOSFETs in that case. So that's really strange. This has acted like a fuse faster than the actual fuse did. This amp's got a 25 amp fuse in it, but that didn't blow. This blew. So this obviously has a higher resistance than the 25 amp fuse, which is not that great. It should be lower resistance than the freaking fuse. Do we have any shorted power supply MOSFETs? I don't think so. Nope, all the MOSFETs seem okay. So it seems that this amplifier was just pushed really hard and this trace just cooked up, you know, just real cooked up. Okay, well, okay, let's first of all then, let's heat the board up. Okay, so the first thing that I want to do actually is add loads more solder to this ground trace because it's obviously not really thick enough for the job anyway. So I'm just going to wait for my soldering iron to get really spicy hot. Hopefully it gets hot enough because it has been playing up recently. Okay, I'm just going to try and bend it back a little bit without snapping it. Please don't snap. Oh no. No. I think it just snapped. Please don't snap. Please don't snap. Okay, it's just about usable. This is the last amp that this soldering iron tip's going to work on. After that, this is toast. It's definitely going to fall off in like 2 seconds. If I apply any pressure, it's going to fall off. Stormy Young, thank you very much for the 5 again, buddy. So should I spend more and get a B2? Which one do you suggest? Well, I don't know. See, that's up to you. Like, the B2 amplifiers are fantastic. Don't get me wrong. But when you're talking about, like, a subwoofer amplifier, it really depends on what you want to do. Like, I can't really tell you whether to spend more on the B2 or save your money. 'Cause if it was me, I would save my money generally. And I would get... if I'm going to buy an amplifier, if I'm going to spend my money on an amplifier, I'm going to spend it on the modern technology, cheap, efficient power, because that's the way forward for these things. So, yeah, I would probably get the Banter 8K. It's an absolute beast. Absolute beast. Alternatively, you can perhaps look at getting the Orion HCCA. I think they're doing 8K of that. That's a freaking beast of an amplifier as well. But it does have some circuit design. Choices that I don't particularly like, and I prefer in the Banter. The B2 stuff, it is definitely awesome. And if you've got a budget of 2,500, then yeah, the B2 is definitely in budget. So I guess, yeah, why not go for it? I guess that I'm quite tight with my money. You know, I like to make sure that I'm getting as many watts for my money as possible. And I guess also it's probably part of that decision is because I know that I can fix it. So for me, I would probably spend half the money on an amplifier that's a little bit less reliable, but it still sounds great. And yeah, if it did blow, I can just fix it. But I guess that's not the same for everyone. So also, the B2 amplifier would cost a bunch, like shitloads more money to repair than the Banter. So that's something to consider as well. If it does blow, how much is it going to cost you to repair? I can do a full rebuild on a Banter Viking 8K for like 130 quid, 140 quid or something. Whereas on the B2 like that, it's going to be like looking at £300-400. So Uh-oh, it's coming, it's falling. It's doing a bend. It's proper bent now. Look at this. Oh, it's gonna fall off literally. 2 seconds, it's gonna fall off. Oh man. Bye. No more soldering for me this evening. Might just have to do there it goes, guys. There it goes. RIP. F's in the chat, please. F's in the chat for my soldering iron tip. I wonder if this still works. It actually still melts solder on the tip, on the internal tip here. I wonder if I can, like, just to finish this off. Yeah, there we go. That's working. Just to finish this off this evening. Fucking hell. You might be thinking, hey Bevers, why don't you just stick a new soldering iron tip? Well, these tips are out of stock, and they've been out of stock for weeks. I've been trying to buy one, haven't been able to buy one, so I was hoping that this tip would last me, and it hasn't really lasted me. But it is still getting the job done without the tip. This is janky as fuck. Okay. Now we need to get some jumpers to go over that broken trace there. Oh man, what are we going to do for the next few days of the live stream? It's Streammas and I haven't got a soldering iron. I'm going to have to like scour the interwebs to try and find me one of these soldering iron tips on quick delivery from maybe even from a different country. because there's none in stock in the UK at the moment. So, sad times. Oh, there we go. There we go. That's cooking it up. Oh, yeah, look at that bad boy. That's going to work a beast. That's going to work absolutely fine. Okay, okay, okay. Yep, yep, yep. Now. Come on. Let's push that over a little bit. There we go. It's not so bad. Oh, you just have to push down hard. That's the trick. Hey, that's not even so bad. That's not even so bad. Yeah, it's gonna carry loads more current than it did originally. That's not even so bad. I'm not even mad. I'm not even mad about that. Okay, so now it should just turn on and work. Let's see whether that was the only problem here. It could be that there's another problem with the amplifier which caused that to blow. It could actually have a dead output transistor that drew excessive current from the power supply, and rather than blowing a FET, it blew the trace. So let's just double check we don't have any dead output transistors here. We have a really low resistance between legs 1 and 3 actually. I think that's normal on these older amplifiers. Got 125 ohms between legs 1 and 3 of these output transistors of these amplifiers. But that's pretty normal in these older amplifiers, so I don't think that that's a problem. I'm used to seeing like anywhere between 3 and 500 between the legs 1 and 3 of like Class D amps and modern Class ABs and stuff. So, okay, cool. Let's power her on. Yep. Let's just spray some aftershave in my USB cable. Don't ask. Don't ask. Plug that back in. Here we go, scope screen. So now we're looking for a nice juicy square wave on the back of this power supply FET. Let's see what we have. Yay! There we go. Lovely jubbly. No DC on the no DC on the outputs, no DC on the outputs, nope, no DC on the outputs. So yeah, a couple of 100 watts, I reckon. So hang on a minute. I wonder, I might actually be able to run this amplifier up to clipping point. I might even be able to bench this amplifier just off my bench power supply. So hang on a minute. That's 20 amps. So I've got 20 amps available to me. What's 20 times 14? 14 for 28. Yeah, that's about 280 watts. I might be able to... nah, with the efficiency, it's going to be over 300 watts, isn't it? So I probably can't bench this. But I almost thought I could bench this off my like low current power supply in the workshop here. But yeah, that's all sorted then. Do you want to see the UV meter, the VU meters bounce? Because that's something pretty cool, isn't it? So should we get some signal playing? Hey, and let's see the VU meters. Do a little wobbly wobble. What are the knobs on the side of this one? What we got? We got gain, control, and frequency. So it's going to be that way up. So 30 hertz frequencies. Go up a little bit on that one. Gain, control, and low pass filter and low input. There we go. There we go, there's a sine wave. And there's clips. So actually, yeah, let's see how accurate are these VU meters in terms of telling us the clipping point. So let's give this amplifier 12 volts worth of input. It's kind of standard, 12 volts. And let's push this sine wave to clipping on the scope. which is just about there. Literally just there. So we've got 15.18 volts RMS. And let's have a look at the VU meter. What is the position of the VU meter? It is... yeah, it's literally... yeah, that's pretty much bang on. It's just over 0. So there is a little bit of clipping going on the scope here. Just a touch. If I back it off a tiny little bit into clean, yeah, that is dead accurate. And then the second you go over that 0 dB, see the wave shape starts to real clip off. I mean, wow. I mean that's a legitimate square wave right there, and it's only showing as plus 2 dBs on the VU meter. So maybe the clipping doesn't really work so well. What about if we pump it up to 14 volts? So obviously when the alternator is charging, we've got a 14.4 volts there, or whatever, 14.3, 14.4. So what happens now then? The clipping point should be higher, which it is. Clipping point's now up here. Interesting. So the VU meter doesn't take into account the extra voltage from the alternator. So as you can see here at 0 dB, 100% output, we've got 14 volts RMS on the scope. As we go higher, we're still clean up to, we start to clip at about this point here. But as far as the VU meter is concerned, we are already at plus 1 dB. So, you know, we would expect it to clip. However, it's still clean because we're up at 14.3 volts. Let's check the other channel. Let's just see if that's the same or not. Yeah, that's pretty much exactly the same. We've got the clip point the same. We're at plus 1 dB on the meter. Just underneath the clipping point at 14.3 volts. Boom, 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 boom. Boom, boom, boom. Boom, 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 boom. Boom. Was those old school bass testers like DJ Magic Mike and stuff like that? Feel the bass, 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 bass. Boom, 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 boom. Yeah, we still can't get to that plus 4, even with a big fat off square wave on there. What about if we max out the gain? Actually, the gain is on pretty much 0. Let's max out the gain on this. We haven't got a speaker connected, so it's fine. Let's see if we can get to that plus 4 dB. Just still can't reach it. Even with full gain and full chat on the signal generator, we still can't get to that plus 4 dB. It's just a little shy of it. But yeah, there we go. Yeah, that's old school power acoustic. Interesting little thing. Yeah, or some of those old bass testers. So from my childhood of like downloading bass testers from LimeWire and Ares on my PC in my bedroom at age like 14, and watching my JVC 6-inch sub bounce. So there was DJ Magic Mike, there was the bass tester, that one, and then you had they were all called like subwoofer tests. There was this kind of Chinesey one that was like ding 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 ding, and it would say bass bass bass. And then there was Woofer Cooker, which started off as a big sine sweep, like, and it would sit like for ages, and you get this like in the background for ages with this like a vocal. What's some other good ones? I love big speakers. Who made that one? It's just like a female vocal. It's like, I love big speakers. Boom, 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 boom. That was another good one. I'm trying to think of some others. Feel the bass. Oh, bass, I love you, of course. Obviously, none of my subs at age 14 could play any of those notes, so just used to watch the excursion. Tektronix, yeah, what did they do? What did those ones go like? I can't remember. Yeah, I like the VU meters as well. I do enjoy VU meters on these amplifiers because it tells the user a little bit more information about how close to the amplifier's limits they are. Like, why don't most amplifiers have like some kind of VU meter on them or LED meter? Like, why? Like, why not? It's easy and it makes sense. It tells the user like You wouldn't buy a car that didn't have a rev counter or a speedometer or even a fuel gauge. Yeah. So when you're talking about a car audio setup, a car audio system in your vehicle, okay, I consider the following thing. I consider the amplifier VU meter, like the car's rev limiter. You need to know how hard you're pushing the engine or the amplifier close to its rev limiter or its clip point. Otherwise, if you try and go beyond that or you up at that point all the time, it's going to blow up. Same goes for the engine, same goes for the amplifier. In terms of the voltmeter, everyone who runs a car audio system needs a voltmeter in their car, because that's like your fuel gauge in your vehicle. You wouldn't drive a vehicle without a fuel gauge. You no idea how much petrol you got left. You don't know when you're just going to pull over on the side of the road and have to call your mum to come pick you up because you run out of fuel. So you need a voltmeter to tell you how much energy do you have left in your batteries. Is your alternator beefy enough to keep your batteries charged up while you're basing? How much power are you using? What's your voltage drop like? So important to actually have devices that give you this valuable information about your car audio system while you're using it. I don't understand why amps don't come with VU meters anymore. Miami bass. Yeah, I don't. Yeah, that one rings a bell. I also had beats for my van. That was pretty cool. Oh, Basshead's Anthem. Holy crap! Yeah, I forgot about that one. Oh man, I was so proud of the lyrics for that. I was so proud of the lyrics to Basshead Anthem. Some of the lyrics were sick. Like there was this middle bit. What did it go like? Shit, I can't remember. 25 hertz, 8 cubes, 1 ohm, sitting on the dash while you... Oh, what is it? Screens on... That's it, screens on dash. 25 hertz, 8 cubes, 1 ohm, screens on the dash while you're sitting on your throne. 400 amps from the cell, running through your zero gauge. In-car entertainment like you're in a nice age. That was the best line, I think. I was proud of that one. My mum's Prius doesn't have a tachometer. Wait, what's a tachometer? Like, where's my tacos, bruv? My tachometer's empty. Give me... yes, tacos rolling in. Munch, munch. Tachometer's full now. Thank you very much. I have no idea what a tachometer is. Bass mechanics. Yes, bass mechanics. Yeah, get a Civic, you can run them on the rev limiter all day. Yeah, get a Torrent Smart 3, you can run that on the rev limiter all day because it has current mode clipping, so it will reduce the sine wave amplitude when you go too high. Would you rather have the VU meter on the Power Acoustics or on the Rockford Fosgate? I can't remember. I quite like the analog power meters. Depends really. Depends how fast the bassline is. I like analog needle style voltmeters because you can see tiny fluctuations in voltage much better than you can on a digital meter, because a digital voltmeter always has a refresh rate, and so any dips that happen in between the refreshes you don't get to see, whereas with an analog one, like with a voltmeter, you don't need to know exactly to the 0.1 of a volt what your voltage is. You just need to know, are you above 14, are you getting close to 12, are you under 12, are you under 11, and with an analog one you can see roughly what your voltage is. You don't need to see exactly the 0.1 of it, but the analog voltmeter will give you the ability to see tiny fluctuations in voltage from like kick drums and stuff like that. That is really useful. Are you going to work with Big D Wiz anytime soon? I don't know. Big D Wiz usually messages me if he wants me to get involved with a collaboration. I am still working on the Audio Pipe 3K. That is becoming a bit of a headache to do the upgrades on. So that's kind of my ongoing work with him, and it's been the case for all year, which is long. Have you ever repaired a computer power supply? Actually, I had a computer power supply that did blow up. Well, not blow up, it just stopped working, or it had some issues. It would work, but then as soon as you draw a current from it, it would just turn off. I did take it apart to see if I could see, like, you know, whether I could perhaps repair it, but to be honest, it was a bit way over my head. And computer power supplies are generally not the sort of thing that you want to try and bodge back together, because a computer power supply, if it fails, it can kill lots of other parts in your computer, your processor, graphics card, RAM, etc. And it's not worth that risk. You might as well just buy a new one. They're not expensive. Computer power supplies, like 60, 70 quid or something, get you a reasonable one, so you don't need to spend the time repairing them. Our tachometer is the speed of the engine. Okay, so rev counter. I actually drove a Proton, a really old one from the 80s that also didn't have a rev counter, so you just had to kind of go by what the engine sounded like as to how high the revs were. I Love Big Speakers is by Bass Boy. Okay, I remember... Well, what were some of my favourite ones? I'm just trying to think back to scrolling through my iPod now. Some of the best ones. Oh, there was a couple by Doffo. Who was there? Like a guy called Doffo who made like tracks like Sound of Waves, or like there was some other one, and there was also Visions of the Future that was like do 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 do. That was a really good one. That was a really good tune. That. Hey Sam, how does a clip limiter on an amp work? Good idea. So Hippopotamus, a clip limiter, what the amplifier will do is there's a couple of ways that they will work. Either the amplifier will detect the amplitude of the sine wave, and once the amplitude of the sine wave reaches a certain point or goes beyond that point, the amplifier will then electronically reduce the gain. It has like electronic gain that it automatically will reduce in order to prevent the amplifier from being in clip on the outputs. Another way that it can do it is that it can limit current going through the amplifier with a current limiter, and that will protect the internals of the amplifier from excessive current due to clipping. Bass, boom, bottom. Yeah, I remember that one as well. You can use computer power supplies as bench supplies. Yeah, you can. Well, yes, provided you want a fixed voltage. The beauty of a proper bench power supply is obviously you can select any voltage between 0 and the limit of your supply. And also, computer power supplies don't have the ability to limit current. So you can't limit the current with a computer power supply like you can with a proper bench power supply. What would cause the amp to put out low voltage? I just replaced FETs, resistors, drive circuit, and now no light goes on and reads low voltage. Low voltage where? What, on the speaker terminals or on the main power terminals? Boom, 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 boom. Holy shit, there's 115 people here. That's quite a lot. Okay, so we finished that power acoustic. So I could put that back in the case, but I'll do that later because that's kind of boring. It's kind of 1 AM here now, and I know that I've only been streaming for 1 hour 14, but these Streammas videos, these Streammas live streams, are going to be shorter than your average 4-hour stream from Bearvidge. So I've been getting to bed at like 3, half 3, 4 AM for the last few evenings. So I think I'm going to call it a night for tonight. I'm going to call it a day. Going to get a nice early night this evening. We're going to come back and we're going to stream a little bit earlier tomorrow. We're going to start the stream around about 9 o'clock UK time in the evening. Work out the time for you. And it's going to be an interesting one because I can't do any soldering. Because my soldering iron has done this. And I don't have any more tips and they are out of stock at the moment in the UK. So yeah, I'm going to have to try and figure out something to do on the stream for you that doesn't require too much soldering. Hey yo, Brandon. Yes, I'm really sorry, my man, but we're kind of wrapping the stream up for now. Yeah, you have to come back tomorrow at 9 p.m. UK time. I'm not sure what that is, different parts of the world, but we'll be streaming around about 9, maybe 10 tomorrow evening. And we'll try and do a really good live stream tomorrow if I can figure out how to do some soldering. I might have to actually go to a hardware store if there's any open during the lockdown and try and pick up like a decent power soldering iron just as a spare that I can use tomorrow. Where can I message you, bro? Go on Facebook, search Bearvidge, click on Bearvidge, click on send message, I will respond. Bearvidge, some audiophile guy claimed when he changed the see-through fuses to ceramic ones in his high-end hi-fi amplifier, it made an SQ difference. No. No, I don't think so. I would like to A-B that. Like, quickly A-B it. I would like to have, what I would do, if I had that set up, I would rig up a big freaking, like, high current switch, right? Or relay or something, and I would have solder both fuses to, like, the different prongs of the switch, okay? And then what I would do is I'd have the amplifier running and playing some music, and I would quickly flick the switch to change between ceramic fuse and glass fuse. And there should be enough capacitance in the amplifier to deal with the tiny nanosecond that the connection is broken during the switch. If you do it quick enough, the amplifier will stay on due to the capacitance and stuff like that. So I don't honestly think that there'll be an SQ difference, and I imagine it's probably all just in your head in that. But I don't know. I haven't tried it, so I can't say. I have not tried different fuses, but honestly, I don't think that would actually make a difference. Scrape and bass, what? What are you saying, please? Hang on, wait, what? Jerry rig it, Jerry troubleshoot. What do you want me to do, dude? Scrape and bass, what do you want me to do? Mike Honda, I say walk through how to troubleshoot an amp and what the components are and what they trace to. That's a good idea for tomorrow. Yeah, we could do something like that. It doesn't require soldering iron. So I could do a purely theoretical, like, you know, troubleshooting video, what things to look for, common problems with amplifiers. I could even go through what equipment you might need to start doing amplifier repair for yourself. Just something that maybe doesn't involve soldering, but we'll see. I've stuck a nail on my soldering iron. Yeah, the problem with my soldering iron is that, so these tips, these have the, is that cool enough? Yeah. These tips have the heating element built into the tip. Let's just wait for the camera to focus up close. There we go. So the heating element is actually built right in there, and it has like a kind of film that connects to the actual soldering tip. So the problem with this is that it has snapped at, the heating element is just in here. The heating element is just in this bit here, and it is snapped from the heating element into there. So I can't really, like, I can't attach anything to that really. Without that, I can't screw anything in or put a nail in there to, you know, allow that to heat up anymore. Mike Honda, dude, thanks for the 15. That's what Scrape and Bass was referring to. Ah, nice one, awesome. Yeah, I could definitely do that. So we'll do something like that tomorrow if you like. Bearvids, video like, see you again tomorrow. Thoughts West Coast Custom 20. Oh, what do I think about it? Yeah, that's actually a pretty decent amplifier. So anything made by Orion generally is pretty good. The Orion amplifiers, the 2500D and the 5000D and all that sort of stuff, they, for their time, for the time that they were built, they were very good amplifiers. Even the new HCC amplifiers are very good amplifiers. They are full bridge and they have done it correctly. They've done it properly. They're using very good components. Yeah, Orion generally do bring out good stuff. The HCCA is a bit of a meme now because people still want £400 for it, even though it's like however freaking many years old woofer now. But I mean, freaking hell, when the HCCA sub came out, that thing was a beast. Like, there was nothing else like it. So yeah, HCCA, Orion amplifiers and subs, pretty good. Pretty good stuff. Rupton says, can you explain how the IRS 21844 turn square drive waves into audio? I could probably explain some of that. Yeah, maybe tomorrow then we'll just do a kind of lesson about how the hell Class D works and how square waves get turned into audio. Maybe we'll do something like that. Or what I'll do then for tomorrow is I'll try and put together some. I'll try and sort of get some stuff on the screen. Maybe get some paper, maybe a whiteboard, maybe some stuff to kind of show you guys exactly what Class D does to turn square waves into audio, because it's pretty interesting the way it works. Yeah, alright, cool. We'll do that tomorrow then. Alright, cool. I'm going to get some sleep now then and prepare that for tomorrow evening. Yeah, guys, take it easy. Have a good evening wherever you are in the world, and I'll see you tomorrow. Thank you very much for joining in, and anyone who donated, massive appreciations. Like, thank you so much for dropping stuff on my channel. Really appreciate it.